Hello everyone, let's try to be a cheat code ninja today. This problem has been asked many times in Facebook interviews. Let's look at it. We are given an array and an integer k, and we have to check if there exists a subarray of size at least 2 where the sum of the elements is a multiple of k. Let's look at the first example. The sum of the subarray 2, 4 is 6. The length of the subarray is at least 2. As 6 is a multiple of itself, hence our answer is true. In the second example, this subarray is of length 5 and its sum is 42. As it is a multiple of 6, hence our answer is true. In the third example, we cannot find any subarray of size at least 2 where the sum is a multiple of 13. Hence the answer is false. Let's try to come up with an intuitive solution for this. Let's consider this example. If we try to solve it in a brute force way, we have to start at every element and find all the subarrays starting at that point, which are of length 2 and their sum is a multiple of k. To check if a sum is a multiple of k, we will use the modulo operator and it should be 0. Since we have to check all the subarrays, our time complexity would be O of n square. Let's try to improvise it. Let's go through the properties of the modulo operator. The modulo operator returns the remainder. If we modulo any number by k, then the possible remainders will be in the range from 0 till k minus 1. For example, if we mod any number by 10, then the possible values will be from 0 till 9. For example, if we mod 77 by 10, the remainder will be 7. Hence, 77 can be written as 10x plus 7. Here, x is an integer. Let's try to use this property to come up with our solution. Let's look at this example. The sum of the subarray 61, 16 is 77. Hence, it could be written as 10x plus 7. The sum of this subarray is 112, hence it could be written as 10y plus 2. And the sum of this subarray is 117, hence it could be written as 10z plus 7. If we look at the sum of these two subarrays, we can notice that the difference in their sums is a multiple of 10 because 7 will get cancelled out. The bigger subarray includes these elements and the smaller one includes these. The difference in the sum comes from these two elements 35 and 15. Hence, the sum of 35 and 15 should be a multiple of 10. We somehow have to keep track of all the remainders that we have seen. If we come across the same remainder again, it means that there is a subarray whose sum is a multiple of k. There is also a condition in our question that the length of the subarray should at least be 2. Hence, we also have to store the indices at which that remainder was found. The ideal data structure for this would be a hash map where the key would be the remainder and the value would be the index at which it was found. Let's look at a complete example. Here, the sum of the first subarray is 61, hence if we mod it by 10, it would be 1. We'll store it in our hash map. Since we are only concerned with the remainder, we don't have to add the next number by 61, we could only add by 1 and it would give the same result. We would add 1 and 16. The result is 17 and the remainder is 7, hence we would store it in a hash map. We would add 7 and 35 and the remainder would be 2 in this case. Now we will add 2 and 15. The remainder would be 7. We can see that 7 already exists in our hash map. So we just have to verify if the length of the subarray is at least 2. Our current index is 3 and previously the remainder 7 was found at index 1. Hence, the length of the subarray would be 2. So we can return true as our output. There's one corner case that we have to handle, which will become apparent by this example. Let's look at it. For this subarray, the remainder would be 1. We'll store it in a hash map. And for the next subarray, the remainder would be 0. Now we don't have any more elements left. We did not find any remainder that occurred twice. But if you look at this subarray 7 and 5, then it is a multiple of 6. Its length is also at least 2. If we assume that there is an element 0 at the beginning of the array at -1 index, then our problem would have been solved. Hence, we should always initialize our hash map with the remainder 0 and its index as -1. So if we had initialized these values, our current index for remainder 0 would be 1 and the previous index would be -1. Hence, the length of the subarray would be 2. So we will return true in this case. The time complexity of this would be O of n because we are going through the array only once. And the space complexity would be O of k because the size of our hash map would be k for each of the k remainders. Let's implement our solution. Let's initialize our hash map with the remainder 0 and its index as -1. Let's initialize our current sum as 0. We have to iterate over our array in a for loop. Let's add this number to our current sum. Since we are only focused on the remainder, let's mod it by k. This would give us the remainder. Now we'll check if that remainder already exists in the hash map or not. If it does exist, then we'll check if the difference in the indices is greater than 1. In that case, we can directly return true. If that remainder does not exist in the hash map, we'll add it to the hash map with the index I. And if after going through the array, we still haven't found any subarray, which is a multiple of k, we'll return false. Let's submit our solution. As you can see, our solution is accepted. If you have any concerns regarding this solution, please mention in the comments. If you thought this video was helpful, please leave a like and subscribe to the channel. Thanks for watching.